will be a review, and so we will have examination 3 is November 11th. It's same as the syllabus. So we are going to do the review today, and maybe a little bit next week, Tuesday. If we finish earlier, the next week, Tuesday, I'll go ahead to lecture the final exam section. Remember, it's not accumulated. Now, final exam, the last day of the class is December 9th. So we'll try to finish everything December 7th. So December 9th in here, that will be the first early final exam you can come in to do. And I also offer you December 10th, Friday afternoon, 1 to 3. You also can do it. 12:30 to 3:30, you also can do it. And then the official university time is December 16th. That will be early in the morning, it's 8 o'clock. Okay, so just let you know, I offer you 3 sections, and that's all. I'm not doing these individual, unless it's very special circumstances. I don't do these things too often, but I can make anything very too special. Okay, so I put out exam practice question 3, practice question 1, 2, 3. We're going to talk about that. Some of them I'll use a question to do a review. Now again, the extra points obviously will be the ATP structure, citric acid cycle, and the glycolysis cycle. The chemicals and the structures. Chemical name is 0.5 and the structure is 1.0. And 1, as long as you write the glucose there, you have 0.5. You write the structure, it is 1. Okay? So that's the extra points. Now, before we go to review all these things, I would love to spend in time to review, and I'll do this review for you today, and Tuesday I want some person to come to the front to do, which regarding lateral operator. Okay, I want you guys to be understand, and we should have a conclusion for this. Okay, number 1, the situation. There is no glucose, there is lactose present. Okay. Number 2 situation, there is glucose and lactose both present. Number 3 situation will be there is a glucose and there is no lactose. Okay, the last situation will be no glucose and no lactose. There is a 4 different situations. We're going to do the conclusion. Now, first of all, let's review again. What is the structure of lactose? We don't want to make sure it is too complicated. Okay, so 3 segments, 1. Okay, this is P, promoter. This is O, operator. This is CAP. Catabolic activate protein site, and lac Z, lac Y, and lac A. Okay, I'll make sure these are exactly the same. Then we're going to talk about this. 3 segments. That P, O, lac Z, lac Y, and the lac A. So same here. One, 2, 3. Should have 6 segments. Okay. Cat, P, O, lac Z, lac Y, and the lac A. Okay, first thing, let's do a review. What is P? Promoter. Okay, what is O? Operator. What is CAP? Catabolite activator protein. You can say protein binding site. Should say. Okay, what is like Z? Beta glycosidase. What is like Y? Permease. What is like A? We will see it is the transacetylase. Or we say just 6, I don't know. Okay, we don't know the function of that. Okay, the first situation. No glucose and the lactose present. What are we going to talk about here? We talk about here is what? There is something like this. Is that right? Called repressor protein. And there is a one big chunk here, which is CAMP. And then we have another thing very special here, which is, of course, RNA polymerase. Okay, so we're going to talk about several things. No glucose, lactose present. Is this going to happen? Is the transcription going to happen? Transcription always from here, okay? 5 prime to 3 prime. What is going to happen? The first situation. The repressor protein will not attach to O, because the repressor protein has been attached with the co-repressor. That is called allolactose, which is a side product when the lactose go inside of the cell. Is that right? With the help of the permease. Glycosidase break down lactose, become glucose. So if you still remember, we're going to do lactose, major is glucose, and glycosidase. Break down glucose and allolactose, galactose. Okay, this is the one we call it a co-repressor. So at this moment, what happened? This co-repressor allolactose comes here, attached to it. Attached to the repressor protein, become a co-repressor. So, the co-repressor protein and the co-repressor, they are not going to attach to the operator. At the same time, because there is no glucose, so what happened? Here, the ATP, the AMP, will become CAMP, using adenyl cyclase. Remember, this is rely on group translocation, if you remember. Okay, so there is no glucose. What happened is AMP will not go to ATP, will become CAMP, and then they're gonna attach to the cap. So this is we call positive control, and this side will be quite a negative control with repressible gene. Therefore, very very important. This is attached. Okay? The RNA polymerase is attached to the promoter. Therefore, they started to transcription and the lactose is used. This is the first situation. Okay, the second situation, there is a glucose and there is a lactose, both present. What is going to happen? If this happens, what is going to happen? You have a repressor protein. This is a repressor. Same thing, the repressor will be attached with allolactose, the co-repressor. So they are not attached to here, not attached to the operator. But how about here? Is CAMP will attach to the cap area? No, this is not going to happen. Why? We have a glucose here. The glucose will become glucose 6-phosphates going through group translocation. So they don't go that way. This way is blocked. So the positive control not work. And remember, lacto offer has to work. They need both positive and negative control. Both work very well. Therefore, this RNA polymerase will not attach to the promoter. So, this reaction 5' to 3' will not happen. Okay? And this phenomenon, we could use a growth curve to explain it. If you remember, this is number, this is time. At the beginning, they grow like this. Then they have a second grow like this. Once they both present, we're going to all talk about is this here. This is the glucose curve, and this is the lactose curve. And this phenomenon of dioxic growth curve, which means in the presence of both glucose and the lactose, bacteria are going to use glucose first, then they start to use lactose when the glucose is depleted, when they used all. So once glucose and the lactose both present, it's not going to happen. This is the second situation. Okay, the third situation, glucose is there and no lactose. What's going to happen? Okay, then, because there's no lactose, so what's happening? This repressor will attach to O. Okay, and how about the cap? Although there's a glucose there, so what happened? This cap will also not going to attach, CMP not going to attach to the cap. Okay, the reason is the same thing. The glucose will become glucose 6-phosphates. And this way is not going to be activated. So in here, how about this guy? How about RNA polymerase?